So let's continue with scenes and geometry. When you have scene geometry, tracking becomes much easier and more efficient. It's completely different from tracking without any location or object reference data. Once you've worked with geometry, you'll definitely feel the difference and will aim to always use it, either by requesting it or building it yourself. Import the shot. Building cache. Set lens parameters. And watch the shot. It turns out it's not that complicated, and in fact, it isn't. Let's go ahead and track the camera and the object. We'll have 2 point groups, one for the camera and one for the object. Let's rename the first point group so it's clear it belongs to the camera. Then we'll create 6 trackers. We create a new point group for tracking the tank, switch to it and start placing trackers directly on the object. Right-click in point groups, add new. A new group appears, give it a name to stay organized, then open the point browser for easier point management. The point browser is essentially the same as the object browser, just displayed differently. All scene points are stored inside the object browser under the point group structure in the points section. Now we have 2 object browser panels open. We can display only the points of the current point group. To do this, in the object browser menu, select Show Points of Current Point Group Only. This way, only the points of the active group are shown. You can also configure what's displayed here. Only cameras, only the point group, or only lenses. We can see that the first point group already has trackers, while the second one has none so far. By switching between groups, we can independently track the camera and the object. Here the camera is tracked, and here we'll track the object. And we also create 6 trackers. At the start of this phase, there's some motion blur, so it's better to place the tracker on a part where there's no motion blur. We create trackers on different planes. The rule is the same here. Don't track just one side, but also capture the parallax. Okay, let's look at the first advantage of tracking with geometry. Usually we need 6 points to solve a camera or object. When tracking with geometry, only 4 points are enough. For example, if we solve the camera now, it works because we created 6 trackers, but in the tank point group, there are only 4 trackers, and the solver says that's not enough to set root frames and calculate the motion. Let's add geometry. We expand the point group, go to the 3D Models tab and right-click Add New, import OBJ file. And we can view the imported model in 3D orientation and in lineup mode. Next, we need to position the object relative to the camera. By holding Shift, you can rotate and move it with the mouse in the viewport. We roughly align the model to the viewpoint seen from the camera, but this isn't very convenient to do. If it's difficult to position the object manually, you can use a point you've already tracked. For example, select a point on the corner of the tank. Then switch to 3D orientation to align the scene through that point. Although it may seem like you were moving the camera, since this is the object's point group, you are actually moving the object. The key point is that the point is known and we can use it to align the scene. I have this point selected and I need to match it to this vertex. With the point selected, I press Extract Vertex. I click on the vertex that this point should match. The point's properties are immediately updated with coordinates corresponding to the model's vertex. If we switch back to lineup, when we rotate, zoom or pan the model, it will now be done around the first aligned point. It's easiest to start lineup with just one point. Here we see that we can't rotate the model to the desired angle, so we'll use camera roll. Camera roll also only works when you have a small number of points used. After that, it becomes locked. And we roughly adjust everything to fit. Approximately, not precisely, because the framework was built by people, even using measurements, it was fairly loose and unstable. So it's enough to position it roughly. How can we position it more precisely? Because we can know the exact correspondence between a point and a vertex. For example, here we can do that. By the way, to hide a model, you can press M or in the viewer panel in lineup mode, toggle the 3D models or geo button if your object belongs to geo objects that you want to hide or show. So, there's one more type of points we've barely discussed, lineup points. Lineup points are essentially very similar to regular trackers, but they aren't used to track an object. Instead, they exist specifically to position and align in viewer lineup, as the name suggests. What do we do next? For example, we identify the corner we want to attach to, press extract vertex, and when the crosshair appears, hold Ctrl and left click. A lineup point is created. This cross is the lineup point. Its coordinates are taken directly from the model. The difference is that if we move to the next frame, it disappears. It's not a tracker, and the solver doesn't calculate it. Such a point is used only for alignment. Either the camera relative to the model or the model relative to the camera, depending on the point group settings. In the viewer, it appears in purple if you look closely. Lineup mode can be tricky, especially when positioning a model, one wrong click and the entire scene shifts. That's why store pose is your best friend. Just saves the current pose, camera or model position. If you've aligned the scene even roughly, save the pose, otherwise you can lose your work. Recall pose. Restores the saved pose. Remove pose. Deletes the saved pose if it's no longer needed. This is especially important when working with lineup points. A single careless move can shift the whole scene. I can try placing another lineup point. Holding Ctrl, I create a new point. I'll save it again because this result can be lost very easily. Again, this is simple here only because our model is primitive. With complex geometry, it's very easy to accidentally rotate and lose the correct position. That's why just pressing recall pose is enough. The scene returns to the saved pose and the camera or model is exactly where you saved it. Almost the same as with a lineup point can be done with a regular tracker. Right in this window, without switching to 3D orientation like before, just select the desired point. Again, we know that it corresponds to this corner on the geometry. We press extract vertex, but this time, without holding Ctrl, just left click when you see the dashed line pointing to the vertex you want the point to snap to. Then left click to confirm, creating the lineup point. The model snaps into place, and the point's coordinates are set in its properties. When using 3D models, you'll notice a higher mismatch between 2D trackers and 3D points. As we can see, it's not perfectly aligned. Even so, this type of tracking is much more accurate than tracking without geometry, even if all points perfectly matched. This is because geometry doesn't always exactly correspond to reality, but it provides far more useful guidance than abstract data you would have without working with geometry. If lineup points get in the way, you can delete them right after positioning the model. It's not necessary to keep them in the project. Moreover, they can vary from frame to frame. The more lineup points you create, the harder it becomes for the model to stay aligned in the frame. In other words, fewer lineup points make alignment easier, more points increase the chance that everything becomes messy. If you lack points and start snapping the model, but it conflicts, simply delete the extra lineup points. Now we'll add a few more and continue. Just like there are extract vertex buttons, there are also extract line and extract polygon. Just like there are extract vertex buttons, there are also extract line and extract polygon. With extract vertex, we set an exact match between a point and the coordinates of a specific vertex. Extract line, however, lets you place a point somewhere along an edge of a polygon. This is less precise. A vertex is a single exact point, so with proper tracking it's hard to make a mistake. With extract line or extract polygon, you choose an arbitrary spot on a surface or edge, and even if it looks like you clicked correctly, it doesn't guarantee an exact match. Therefore, these methods should be used carefully and deliberately. It might help a little, of course, it's better than nothing, but it's unlikely to be precise enough to prefer this method over others. To reset a point's coordinates, simply switch its status to survey free. The coordinates are cleared, and the point becomes free again. Now let's snap this corner. I'll create a lineup point using Control. Again, here you can't specify an exact spot on the polygon like with a vertex, but if I'm confident the geometry is positioned correctly and there's no suitable vertex in the needed area, I can still proceed. If I see that the faces align, the corners are straight, and they match the image, I can simply project the point onto the geometry exactly where it visually appears in the camera's projection. So here I see this point is definitely somewhere around here, in this spot. Yes, and even just looking from the camera view, we can tell precisely, here it is, this point should be exactly here. In such cases, it's very convenient to use the project point onto geometry function. Here's what we do. Select the point, go to Edit, Project Points on 3D Models. 3DEqualizer reports success, 1 point projected. You can immediately see that the point now has a 3D representation in the correct place, and its properties show the exact XYZ coordinates. Now the point really lies where it should, in the correct position on the geometry. Okay, there's still one more point. Let's see what it is. You can also save the pose and slightly adjust the geometry to fit this specific spot. What else you can do? Since the model can shift slightly due to the flexibility of the framework and other inaccuracies, I first roughly align the geometry to the image and only assign coordinates to points after local adjustments. If the geometry slightly diverges from the image in a certain area, locally adjust the geometry to fit the image, then project the point in that spot. If there's a mismatch elsewhere, adjust the geometry for that area and project the point there. This way, each point is assigned using the most accurate local projection, even if the geometry doesn't perfectly match the entire scene. Edit Project Points on 3D Models. And now the coordinates appear, and the point itself is placed right here. So now we have 4 trackers, the same ones we previously tracked. Lineup points can be kept or deleted. They don't affect the result. I'll delete them for clarity, so it's easier to see that only the same 4 trackers remain, which hadn't yet been used to calculate the object's motion. Now we go to the Calc menu. Calc all from scratch. Now the tank point group has been calculated. We apply the result and take a look. One of the great things about geometry is that it helps unify the scene scale. Not only does it make tracking easier and more convenient, but it also makes the work more accurate. If you track the same objects used across multiple shots, the geometry ensures everything is in the same scale, in the same scene, and in the same position. We can check how the tank moves. Overall, this roughly matches its movement. We can make adjustments, but that's fine. How can we further improve the result here? We can see that, for example, in this area, the geometry aligns quite well. But over here, it's clear that when the structure passes over a mound or uneven ground, one part stays in place while another slightly deforms. In such cases, you can carefully adjust the geometry locally, using the image as a guide and fitting only the specific part of the model that needs correction. And again, this may formally increase the numerical track error because the solver will think, well, it fits here, so it should fit there too. But you're specifying that the point should be in a different location. However, the track quality actually improves because we're aligning it to reality, not just raw numbers. This illustrates that you should focus less on the deviation browser and numerical error and more on visual correspondence, on how the track actually fits and matches the image. It's very difficult to track the roof here because it deforms a lot. Tracking such areas isn't ideal. What can we do? We can correct the movement using saved poses and the transposes function. Save the desired pose, adjust the geometry visually, and then use transforms to correct the object's motion. We save the object's position at the current spot, at the end, and at intermediate frames where it still aligns well. So from here the misalignment almost immediately begins, and it ends somewhere around here. Around frame 7, we'll adjust the geometry using a lineup point. Save it. Now we can recalculate the motion again. And then use transposes to align the current motion with the keyframes we set. Open the transposes panel, select all the keyframes relevant to our motion, and click transform. Now we see that the motion remains the same. The start and end points are preserved, but the trajectory is fitted to the movement we slightly adjusted. Let's tidy up the scene a bit. Right now the tank is moving slightly below the ground and its exact position isn't clear. Even looking from the camera, the depth hasn't been properly calculated again. We can see that the camera is standing still and looking straight ahead. All the points, which ideally should be spread from foreground to background, lie roughly in a single plane. As a result, the camera, which should be tilted about 40 degrees toward the ground, is almost looking perfectly horizontal instead of down. Consequently, the points are too deep in the areas where they should be closer to the surface. Again, we can simply create a plane, roughly align it as the ground plane, and then use Shift in lineup mode to position the camera relative to this plane. For now, we ignore the tank. We can also project key points onto this plane. This will help set the camera at a more correct angle relative to the scene. If we proceed, we can already see that the camera is positioned above the ground and looking down. This is much closer to reality. Now we can select these points and project them onto the plane. This way, 3DEqualizer will understand the scene depth, which points are closer and which are farther. It's convenient and powerful, especially when there's no geometry. You can imagine a plane to simplify the task and make the track more accurate. In our case, we already have the geometry of this field, so it makes sense to use it. I delete the plane and import a terrain geometry. We'll orient the camera using the terrain. The exact camera position is unknown, but here we have trenches, so we can confidently say the camera was roughly in this area. Using Shift, we place the camera approximately relative to the location. This makes it easier to fit it to the actual geometry. Next, to align relative to a specific point, I take this tracker. It currently has no coordinates. Select it, then go to Edit. Project points on 3D models. Now the point is projected onto the geometry. Its coordinates appear in the properties. At this stage, everything is positioned roughly by eye. Later it can be reprojected more precisely. The key is to have at least one reference point to rotate around. That's why it's easier to start with a single point. When rotating in lineup mode, the camera will rotate around it. If you project all points onto the geometry at once, rotation becomes much harder. The scene resists because all points are rigidly constrained. Here I need to adjust the scale roughly by eye, so for now we'll assume I like this camera position. I'll save it just in case. Then I'll project the remaining points. Now when I calculate, first, the camera will remain in the same position in this frame. Second, I can check how well the tank model sits on the surface. Based on this, I'll move the camera closer or farther from the ground to adjust the scale. Calc all from scratch. The points are already distributed in depth. Now it looks like this. From this angle, it's clear. Everything will look fine. You need to check everything in 3D space. And the tank is positioned slightly above the ground level. This means the camera should be positioned closer to the ground, since the tank's scale is already correct and doesn't need adjustment. We know the trackers on the tank are accurate, but the ground was set roughly by eye, so there is clearly some discrepancy. We'll position the tank on the ground. Switch back to lineup and save the current pose. You can either zoom in manually, or if you need to rotate around a specific point, temporarily set the other trackers to survey free to rotate around a convenient point, then switch them back. Once the geometry is adjusted to the desired position, select the relevant points and reproject them onto the new location. For example, if a point was previously projected here, now project it onto the ground surface rather than the tank, which is currently blocking it visually. Also, previously this tracker was projected here, now we'll reproject it onto this new location. Edit. Project. Right, and it reported that only one point was projected. Interesting. Now project the remaining 5 points. 3DEqualizer can be a bit finicky. Sometimes points don't project immediately. Nudging the geometry or slightly adjusting the camera usually makes it work. After projecting all points, recalculate the scene and check how the tank now aligns with the ground surface. Right, the tank is still slightly above the ground. Let's move the camera a bit closer to the terrain to adjust the scale and bring it down visually. I'll switch it to survey free. Now again, I'm moving the camera relative to this point. And I project the trackers onto the new positions. 4 out of 6 were projected, 2 remained free. We check which points they are and why they didn't snap to the geometry. They might have been out of view, behind the model, or near the edge. I nudged them slightly. Now everything is projected correctly. And the remaining point has been projected. Let's calculate. And now it seems we've slightly overdone the scale in the other direction because the tank model is a bit below the ground. Right now we're doing this by eye. Normally, we align using spots in the geometry that we know exactly correspond. Here, it's already difficult to match precisely without additional data. For this example, however, this will be sufficient. One more iteration. The tank sits well overall. When we play it back, the movement looks correct. This is how we solved this shot. Again, using geometry makes it very easy to transfer the result anywhere. Into Lineup, a 3D editor, or a compositing package. This example shows how simple, convenient, and accurate tracking can be when you use geometry. So, if you're going to shoot material for tracking, make sure to take all measurements, create geometry based on them, either directly in 3DEqualizer, in external 3D software, or via reference photographs, and bring it all into 3DEqualizer to track relative to that geometry. The result will be much easier to achieve and far more accurate overall. Now, one more thing we shouldn't forget is correcting the tank's movement after recalculation. The transposes adjustments we do are reset every time we recalc. So if we go to this keyframe, we'll see that the position drifts again. That means we need to redo this operation every time after a recalculation. As tedious as it sounds, it's necessary. While working with the camera, this step may not have been needed. But once we're ready to export the final result, we must perform all final corrections, and that's how it's done.